All right, so this is question 4 of the 13.1 homework. First, I'm going to just talk briefly about what we're even talking about in 13. In chapter 13, we are talking about ANOVA tests, and that is an abbreviation for one-way analysis of variance. And so basically what we're going to be talking about is comparing means from 3 different populations. So this question right here, the different populations are the types of plots, and they're testing to see the number of corn plants in randomly sampled rows. So for these types of questions, our null hypothesis will be that all of them are equal to each other, just like here. And our alternative will be at least one of the means is different, because this right here, an agricultural researcher wants to know whether the mean numbers of plants for each plot are equal. And so even if just one is different, that means they're not all equal. So this one will be our answer. So now we're going to be talking about the requirements for ANOVA. This is from the PowerPoint that you guys all have access to. They're the 4 requirements that they all have to be independent. The populations have to be normally distributed, and the populations have to have the same variance, and there must be a sample from each population. So, and then K, you'll see K a lot when we're talking about ANOVAs. That's just the number of samples. No, because that's what we're testing. Yes, there has to be a random sample from each of the populations. They have to have the same variance, populations have to be normally distributed. Oh wait, what's the difference between that and this? Oh, this one's wrong. Same population. No, we want a simple random sample from each population. Okay. So now we are going to do an ANOVA test. And let's see. Oh, they did it for us right here. So that's awesome. So this right here, this F will be our test statistic. I'm going to do it in StatCrunch just so that you guys know how, but feel free to skip past this if you want to. Okay, so in order to do an ANOVA test in StatCrunch, we are going to go to Stat, ANOVA, one way. And we're going to select all 3 columns and just click Compute. It's that easy. Now there's a lot of numbers here. For the most part, and I don't want to say this, but it's true 100% of the time, but we're just going to be looking at the F-stat and the p-value. Think of the F-stat like the t-stat in chapters 10 and 11, or the chi-square number from chapter 12. And then our p-value is always going to be our p-value. And these are the same numbers that we have here. And I don't know, it might ask you about the degrees of freedom, but I don't know if it'll ask you about these two. So we're going to compare. We have a 0.5 level of significance, and our p-value is less than the level of significance. So the same rule that we've been doing this whole time. If the p-value is greater than the level of significance, then you fail to reject the null, and if it's less than, like in this case, if it's less than the level of significance, then you reject the null hypothesis. So we're going to reject. And we reject the null because there is sufficient evidence to conclude that the alternative is true. Okay, now we're looking at a box plot, and they give it to us. But if you ever need to make a box plot, I know you will in the future, you just go to Graph and then Box Plot and then highlight these 3, and that's what you would do. But anyways, they already gave it to us. So we look at these box plots. Let me make this bigger. And we're talking about the means, and the means are represented by this line that's in the middle, right there. And if you notice, they aren't the same, right? And so does it support what we said? Well, what we said was that the mean number of plants are not equal. And so yes, it does, because that shows that they're not equal. At least one of the means is significantly different. Okay, so correlation coefficient. With the correlation coefficient, so it shows us the residual right there. And the residual is supposed to be greater than the critical value. So you'd say that. And there we go, that's it.